For today's lesson, we will be solving equations, and our standards are as follows. We have the first one of 6EE5, pretty lengthy one there. And then our second standard for today is 6EE7. All right, so in the book, if you were to follow along in the book would suggest using substitution as a method of solving equations. I don't believe that is the most efficient way to solve equations, especially as you move through school and the equations become more complex. So I do not focus on substitution. Instead, I focus on teaching the students how to use the balancing method for solving equations. And for the balancing, you do look at what resembles a seesaw or a teeter-totter right here, where you've got one side of your equation here and the other side of your equation right there. And you utilize those to help you solve your equations. So this equation is x plus 5 equals 8. And I'm just going to write it a little bit bigger to make it easier for me to work with here. Okay. And what we want to do is we want to isolate the variable, which means we want to get that variable by itself. Well, right now we're adding 5 to the variable. So in order to isolate the variable, we need to do the opposite of that. And so the opposite of adding 5 is subtracting 5. So we can think of this as we've just taken 5 things off of the left side of our scale. Now, if we take 5 off the left side of the scale, our scale is no longer balanced, and equations need to stay balanced. So in order to keep the equation balanced, we would then take 5 off of the other side. Well, plus 5 minus 5, they're going to cancel each other out. So on the left side of the equation, we have x. And if we take 5 off of the right side of the equation, 8 minus 5 is 3. So the value of our variable is 3. And if we put that back into our equation, if we put 3 in for x, 3 plus 5 does equal 8. So that is a correct answer to our equation. Another example, again, we have that balance scale there right in the center. And I'm just going to rewrite our equation. So we have 3x equals 12. So in order to balance, again, we must isolate the variable. In order to isolate the variable, we must do the opposite of what's taking place. And since 3x means 3 times x, we're going to do the opposite of that, which is to divide by 3. And since we're dividing one side of the equation by 3, we have to do the same thing on the other side to keep it balanced. So we will divide both sides by 3. The 3's cancel each other out, so we're left with x. And then 12 divided by 3 is 4. And if we were to put that back into the equation, 3 times 4 does equal 12. So if we're trying to figure out for what value of x, will x plus 3 equal 7? So to solve, we would subtract 3 from both sides. The 3's cancel out, so we're left with x equals 7 minus 3 is 4. And 4 plus 3 is 7. For number 2, we're going to subtract 6. Remember, we are not using the substitution method. So if you ever see directions that say to use substitution method, you can ignore that and do the balancing method, which we're doing here. So P would equal 7 because 13 minus 6 is 7. For number 3, r plus 4 equals 12. So we're going to subtract 4 from both sides. We're left with r. R equals 12 minus 4, which is 8. For number 4, it says k minus 10 equals 7. So remember, we have to do the opposite. And since we're subtracting 10, we need to make sure on number 4 that we add 10 to both sides. And we would get k equals 17. Because 17 minus 10 is 7. For number 5, 2m means 2 times n, so we're going to divide both sides by 2. And here m would equal 3. Number 6, 4n equals 20, so we divide both sides by 4. N equals 5. For number 7, we have 1/5 z equals 3. So we would divide both sides by 1/5. And since we're dividing by a fraction, we can follow our rules for dividing fractions. So we keep the 3, turn division to multiplication. We use the reciprocal of 1/5, which is 5. And so z equals 15. So here we have some more equations where we're using addition or subtraction. So if we have x plus 6 equals 9, we're going to subtract 6 from both sides. So x equals 3. Now for part B, solve the equation 6 equals x minus 3. We've just flipped those around to opposite sides. Nothing changes. Since we're subtracting 3 from x, we'd want to add 3 to both sides. And so 9 equals x. X plus 8 equals 19, so we're going to subtract 8 from both sides. So x equals 11. Sorry, I like to do these in blue, so I'm just going to rewrite that real quickly. Sorry, just kind of my thing here. Same thing. All right, for number 9, f plus 5 equals 14, so we subtract 5 from both sides. F equals 9. Number 10, 26 equals g plus 11, so we subtract 11 from both sides. G equals 15. For number 11, w minus 6 equals 10, so we add 6 to both sides. W equals 16. And finally, number 12, z minus 9 equals 21. So we add 9 to both sides. Z equals 30. Part A, solve the equation 2x equals 12. I'm just going to rewrite that a little bit bigger. So as we said before, since we're multiplying x by 2, we're going to divide both sides by 2. So x would equal 6. For part B, y over 3 equals 4. Well, y over 3 stands for division. So in order to isolate our variable, we need to do the opposite. So the opposite of division is multiplication. So we're going to multiply both sides. And to show that, we're going to put the y over 3 in parentheses. We put the 4 in parentheses. And since we're dividing by 3, we're going to multiply by 3. The 3's would cancel each other out. So we're left with y. And 4 times 3 is 12. So y would equal 12. So for number 13, 3x equals 27. We divide both sides by 3. X equals 9. 6a equals 42. Divide both sides by 6. A equals 7. 65 equals 13b. Divide both sides by 13. B equals 5. Number 16, m over 8 equals 9. So multiply both sides by 8. So m equals 72. And number 17, 12 equals n divided by 7. So multiply both sides by 7. 7 times 12 is 84. So 84 equals n. If we have fractions, it's the same thing. So x plus 1/10 equals 3/10. We're going to subtract 1/10 from both sides. 3/10 minus 1/10 is 2/10, which we would then simplify down to 1/5. And then if 3y equals 2/3, we're We're going to divide both sides by 3. So we're going to have y equals, we're dividing with a fraction, keep times turn, so y equals 2/9. And then our final examples today, x plus 3/7 equals 5/7. So we're going to subtract 3/7 from both sides. So x equals 2/7. For number 19, we're going to subtract 1/8 from both sides. So k equals 6/8, which simplifies down to 3/4. And then for 20, we divide both sides by 4. So p equals, keep 3/4, change division multiplication, use reciprocal of 4, which is 1/4, and we would get 3/16. And there is today's lesson. As always, I hope this helps.